Hello students, in this video we will be discussing about alpha particle scattering experiment. In this experiment, this is the figure of the experimental objects or instruments that we have drawn here, and this experiment was done by Grieger and Marston, the students of Rutherford. After the experiment, Rutherford came to the conclusion that we will study on, and in this experiment, this is the radioactive source which ejects the alpha particle or the positively charged particle with a very high energy, and that gets striked into the other metal. This is the metal foil. This is made up of gold, which is around 2.1 into 10 to the power minus 7 meter thin. And these are the detectors which detect the total number of alpha particle striking into these, and also it will detect the angle made by the alpha particle after getting deflected from its original position. These are the collimators. Collimators allows the alpha particle to move along the straight line or the direction that we need, and these are made up of lead bricks. So from the experiment, Rutherford had concluded that most number of alpha particles are passing without getting deflected. Without getting deflected means most of the atom, the part of the atom or the volume of the atom is empty. Okay? Most of the volume of the atom is empty. The second conclusion that Rutherford came into it is some alpha particle are deflected by very small angles. Some of the alpha particle are getting deflected, and they are getting deflected by very small angle. This shows that the positively charged particles are very rarely distributed in the volume of the atom. And the third and the most important conclusion was only a few number of alpha particles, that is somewhere around 0.14% was deflected by 180 degree. It means here where these alpha particles, we have studied that these alpha particles are getting striked on the gold foil by a very large amount of energy, and if they are getting deflected back by around 180 degree, it means something is here which is also a heavy part, and this heavy part is nothing other than the nucleus, which is containing the positively charged particle, where the mass of the atom, the whole mass of the atom is totally concentrated. So this was the experiment that Rutherford has concluded, done by the Grieger and Marston, the students of Rutherford, and this is what the conclusion we have got. And this is somewhere a rough diagram or the rough imagination of atom from this experiment that Rutherford has. Here we will be discussing about the trajectory of the alpha particles that is made after getting incident on the gold foil. So from the first conclusion says that the most number of the alpha particles were passing through the gold foil without getting reflected. So this was the scenario. And the second one was that the few number of or the some alpha particles were getting deflected. Here some alpha particle are getting deflected from the nucleus, and only a few number of alpha particle, let us consider this one, is coming near the nucleus and getting reflected back by an angle of 180 degree. And the distance up to which the alpha particle got near to the nucleus, and this distance, let us consider this is d, and this distance is known as closest approach. This is known as closest approach. And by the angle these are the deflected alpha particle rays from the nucleus, and the distance, this is the original path of the deflected alpha particle, this is the alpha particle, and this is the original path. Here is the alpha particle and this is the original path. The distance, the normal distance between the original path of the alpha particle and the nucleus, let us consider this is P1, this is P2. These normal distance are considered as the impact parameters. This are the normal distance between the direction of alpha particle, that is these are the direction of the alpha particle, and the nucleus, and this is known as impact parameter of that alpha particle. Let us consider this is particle P1. Okay, this is particle P1, and the distance here is p1. Okay, this is alpha particle and this is getting deflected by an angle theta, and the normal distance between the original path and the nucleus, this is known as p1. Now we will understand why the alpha particle was not able to strike the nucleus completely, why it is getting deflected from some distance that we have studied as closest approach. This is happening because alpha particle is also positively charged. Alpha particle is also positively charged, and we have studied that nucleus also contains a positively charged particle, not air, many positively charged particles. And we have known about it, the like charges repel each other and they are repelling each other. So what is the amount of force by which the alpha particle is getting reflected? That we have studied in Coulomb's law, that force is equals to 1 by 4 pi epsilon naught q1, that is charge on first particle, multiplied by charge on second particle, divided by the distance between them, square of distance between them. And this Coulomb's, the force of Coulomb, in the Coulomb law we have studied, the Coulomb's force is actually a greater amount of force as compared to gravitational force and other things. So here the force created by the nucleus on the alpha particle is really greater, and that is why it is getting reflected back from a distance, and that distance is known as the closest approach. We will study about it, we will find the value of it also later on in the later classes. Here, when the alpha particle was getting ejected, here alpha particle was having some velocity, and due to which it was having some kinetic energy, and at the point, at the closest approach, at the closest distance to the nucleus, here the velocity got 0, and when the velocity got 0, the kinetic energy was 0, and when the kinetic energy was 0, here the potential energy was maximum, and that was equal to the kinetic energy earlier here. So this is what the trajectory of alpha particle that we had to study, from the Rutherford's experiment. Thank you very much for watching the video.